but that is my idea. I think there's evidence for it. In fact, I just read something coming down on the plane about possibility of man causing them. At least they think, but it could have been natural fires associated with some mammoths up, I forgot where now. But I think it's a factor, but I don't, I think it's a minor player, but I think it's a factor. I think the windblown dust is probably the major factor for the extinctions. And drought, like Australia, I think that was mainly drought that killed off those 90% of large mammals down there. So fire is a minor player, and it's just, there had to be fires, I would think, if there was grass and trees. And so and I think there is evidence for it. I can't tell you much about it now because I can't recall it. Yes?
According to the Bible and Job, where do you think he lived with the wildlife we talked about and evidence of cold weather, ice age, and different references such as that?
Okay, the question is in Job, where do I think he lived and saw that wildlife? I suppose you're thinking of Leviathan and Behemoth, and he does mention ice and things of this sort. I think I'm sure he lived in the Middle East. As far as his sightings of ice and snow and all that, he could probably observe that in the wintertime. So I'm not sure. I don't think he has statements about the ice age in Job. I think he's just seeing what he sees in his environment. And I mean, if he goes into the mountains, he's bound to see a lake frozen over, and he's bound to see snow. So I'm not sure. I don't think those verses that refer to ice are referring to the ice age in Job. As far as Behemoth and Leviathan, I'd lean pretty strongly that those were types of dinosaurs or marine reptiles. And so he probably lived down around the Jordan River, be my guess. Somewhere in there. Now, that's all I know. I don't know a lot about that. Some people here probably have a better estimate on that, but so that's all I can say on that. Yes?
You have a diagram about some kind of antelope and use it as an example as to why the layers of ice formed right after the flood. Why is it that those antelope couldn't have died in the flood?
Why couldn't what die in the flood?
Some kind of antelope.
Antelope. Oh, because the antelope are found in the superficial soils that are frozen. They find, like the saga antelope that I showed you the pictures of, the distribution of during the... See, there's a recent distribution, historical distribution that I didn't tell you about, and then an ice age distribution. Are you talking about that?
I think so.
Okay. And you're asking why they didn't die in the flood? Well, we probably did have antelope die in the flood, and as fossils. I think there are a fair amount of antelope fossils, but the context of these are in the surface sediments, in post-flood contexts. In windblown silt, for instance, windblown silt is likely a post-flood silt that formed in the post-flood. But so that's why I feel that they died after the flood during the ice age. Okay. Yes?
Further comment on global warming?
Bill was asking me about that during the intermission. Yeah. Okay. Global warming. First of all, between 1350 and about 1880, we had global cooling, called the Little Ice Age, where all the glaciers in the world advanced. Then about 1880, it reversed, and now most of them have been receding. And we've also had other features like temperature records that indicate it's warmed up about 1 degree Fahrenheit in about 100 to 120 years. 1 degree Fahrenheit, that is all. I've had, there was a student from the Montana State University that wrote a letter to the editor, to the Bozeman Chronicle, saying, it warmed up 3 degrees. No, 30 degrees. And he later corrected and said he added an extra 0 by accident, but still 3 degrees he was off by 3 times as it was. It's only 1 degree. Okay, we got out of the Little Ice Age, which we have lots of historical record for cool temperatures over a good part of the Earth, and now we're in the warm cycle. So I think a good part of that 1 degree Fahrenheit, maybe half, is related to natural warming, probably because there's less volcanic ash in the stratosphere than we had in the Little Ice Age, and we might have a little more power coming from the sun, a little more sunlight. Now, about in the 1700s, we had what's called the Maunder minimum, where we had very few sunspots. The fewer the sunspots, the less solar energy comes from the sun. And so we definitely know we had cool periods during that Little Ice Age due to less power in the sun. Now we have lots of sunspots, so it's likely we have a little more solar radiation. Now, some evolutionary scientists believe that, and they believe that the same as me, that some of this global warming of 1 degree Fahrenheit is due to natural fluctuations. We're also adding carbon dioxide to the atmosphere. And theory says that, well, that should heat, and I think that's right, except they run these models, these climate models. There's about 15 of them that they run. They have slightly different, but what they do is they leave all the variables the same, but they double the carbon dioxide in the model to see what the effect of doubling carbon dioxide does. And they get temperature changes all the way from 3 degrees Fahrenheit up to about 10 degrees Fahrenheit. 3 degrees to 10. But nature has run the experiment most of the way already, in that we've increased carbon dioxide 30%. Other greenhouse gases we've increased in carbon dioxide equivalencies of another 30% carbon dioxide, like, for instance, methane. And so, therefore, we have essentially increased carbon dioxide 60% since about 1880. And we've only had as much as 1 degree Fahrenheit, possibly only a half a degree Fahrenheit warming from that, with a 60% increase, and yet they double it at 100% and get 3 to 10. Well, those models are way too sensitive to carbon dioxide, is what they're saying. And yet the environmentalists and some of the politicians will focus in on what those models have done, and also maybe the sea cap in the Arctic decreasing and a few things like that. And they jump to a lot of conclusions and say we got to act now and spend $100 billion a year or something to that effect each year for many years to solve this problem. So I think that's why I say that there's so much hype going on, that 90% hype. What we need is more research, more calmness. And the UN needs to listen to the naysayers, the atmospheric scientists like Richard Lindzen of MIT, listen to them and get the naysayers and the yay-sayers together and issue this. Otherwise,